E depois no final, portanto, já estamos a gravar neste momento, we are recording now the webinar. E depois no final nós teremos a oportunidade, através do Gonçalo Alves, fazer de alguma forma um resumo das principais conclusões que nós retiramos deste webinar. São bom trabalho, Diana, naquela expressão inglesa que não faz sentido nenhum para nós, que é o chão é teu, the floor is yours. Não sei o que é que isto quererá dizer, mas força.
Então, como o Rui já tinha dito, a sessão está a ser gravada, as apresentações vão ser disponibilizadas, dizer isto para quem chegou agora mais recente, tem a opção com as legendas em português e agora vamos dar início também aqui à apresentação destas empresas e destas tecnologias inovadoras com o Yair, que nos vai falar também, mas em português, e depois damos então início às apresentações em si. Quero também dizer que caso hajam questões, que podem ser colocadas diretamente no chat e depois serão colocadas a quem vai fazer a apresentação, ou após as apresentações irá haver aqui um período de questões, portanto, é como preferirem, ou colocar por chat, ou depois nesse espaço dedicado às questões, está bem? Pronto, Yair, pode
Olá, bom
fazer
dia
a
a
sua
todos.
apresentação. Obrigada.
Obrigado. Antes de tudo, eu queria dizer que o meu português não está perfeita, ok? Mas eu vou tentar fazer o meu melhor. Meu nome é Yair Sayag, sou israelita e português. Eh,
Sim,
Vivo
sim.
vivo em Portugal há mais de 20 anos e sou um empreendedor nas áreas de tecnologias, inovações, startup agrícolas e projetos agrícolas em grande e média escala. Eh, o meu principal foco é trazer para Portugal novas tecnologias e inovações para sejam necessários no mercado, que sejam necessários no mercado. Fundamos o WaterPure juntamente com Gonzalo Alves, que é engenheiro florestal e empreendedor na área, e o meu colega, o Tomer Knisnik, que vive também em Portugal nos últimos 2 anos. E Tomer lidera projetos relacionados com água em vários países do mundo, junto com o Pilgrim. Pilgrim tem mais de 50 anos de experiência no mercado e dos principais empresas do isso setor em Israel. O nosso objetivo é claro, é fornecer soluções para desafios hídricos existem em Portugal. Utilizamos nossas tecnologias e grande experiência que adquirimos ao longo dos anos. Hoje vocês terão mostra de nossas capacidades, tanto tecnologias práticas e científicas. Não podemos apresentar todos, mas pelo menos algumas para vocês entenderem o nossa capacidade. No lado acadêmico, temos aqui o professor Ori Lav, do Technion do Haifa, em Israel. Para quem não conhece e não sabe, o Technion é um instituto de tecnologia de Israel, é uma principal universidade de Israel, eh, nas áreas de engenharia, ciências exatas, medicinas e tecnologias. E pronto, queremos agradecer o Diana, a Karina, o Fenareg, que sem os quais este webinar não terá sido possível. Eh, Após o webinar, vamos marcar reuniões individuais com cada um e podemos falar, sentar e entender os problemas de cada um e trazer soluções. E eu vou passar a palavra para Tomer, que vai apresentar algumas de nossas tecnologias que já foram em vários países. O Tomer vai mostrar para vocês os projetos que fizemos no mundo todo. E pronto, só queria agradecer e vamos lá. Obrigado.
Hello, I guess this is my turn, yeah? So my name is Tomer. I still working on my Portuguese, so I will do the presentation in English. Let me go through some slides. Okay. Right, so today I would like to represent to you some of the technologies that we are using in Israel and other places in order to improve water quality. This technology is produced by Palge Mayim, which not only produce the technology, but also implement it in the field with many years of knowledge and experience. So, few words about Palge Mayim. So Palge Mayim is exists for just over 50 years, specialized in flowing infrastructure when it comes to design, build, and operate water systems such as lagoons, water treatment plants, etc. In Israel, the country is defined as desert, and we don't have much water. So we had to find a solution to irrigate crop and to create new water sources. And in Israel, more than 90% of the agriculture is irrigated by treated sewage water. So the country have water treatment plants all over the country, and main pipeline that supply treated wastewater to growers all across the country. Just to touch two mega global trends nowadays, there is a lot of attention for public health and for climate crisis. And the way we can contribute to improve it is to reduce the use of chemical in our processes and to reduce the energy consumption in our processes. And I will touch in a minute how we can achieve this using the technology that I present to you today. So the technology that we are presenting today, the nanobubble technology, it's working very efficiently when it comes to energy consumption. We can treat, depends on the application, but to give you an idea, we can treat reservoir size between 50,000 to 100,000 cubic meter with an energy consumption of 7 kilowatts, which is very little amount of energy. And we also do not use any chemical in the process. It's 100% chemical free, which help us to reduce the chemical usage in our water treatment processes. And we significantly improve water qualities. I'll touch a bit about the nanobubble and its properties. So the average diameter of a nanobubble is approximately 100 nanometer. This is very little bubbles that don't beyond on the surface and can stay in the water for a very long time. They have high internal pressure, which create a situation that the surface of the bubble have negative charge, which attract positive ion to attach to it. and also enable us to contain relatively high amount of gas or oxygen or whichever type of gas we would like to implement in the bubble. The bubble can hold quite a significant amount of gas with comparison to its size. And this creates a situation, if we take, for example, the application with ozone for disinfection and powerful oxidizing mechanism, it's created a situation where we have a bubble that contains ozone inside, for argument's sake, and the ozone come in touch with the water, and then it's converted back into O2, but create a very high level of DO on the surface of the bubble, which enable very efficient oxidizing process. And because it attracts positive ions to attach to the surface of the bubble, the moment pathogens, for example, come in touch with the bubble, they get oxidized very efficiently. Just to give you an idea, on the surface of the bubble, we can get to DO level around 20 to 30 ppm, which is much higher than what we can achieve when we oxidize the water itself. And the bubbles are stable for the time. They can last in the water for a long time and creating like long-lasting oxidizing process. So this is just a bit about the bubbles and its property. I will run through a short film that will show you how the applications looks like, how it looks in the field. So we don't have sound for this video on the webinar, but I will talk through it a little bit. So here it's a bit of demonstration how the positive ions get in touch with the surface of the bubble and oxidize, what I tried to explain on the last slide. Very low carbon footprint, meaning that we consume low amount of electricity to make a significant effect in the water. The system is made of mainly two components. We have ozone generator. We're using small ozone generator of about 50 grams per liter. When we lock the ozone in a bubble, we can create significant effect in high volume of water by using relatively low amount of ozone because it doesn't break very quickly. The second element is the floating system that you can see in the film. And the floating system generate nanobubble and inject the ozone into the nanobubble. The ozone generator will be located in a separate room on the shore. And we have this system in different type of applications like municipal and industrial wastewater, lagoons, reservoir, wastewater treatment plants. We can help in number of places in the process in water treatment plants, removing bad smells from reservoirs water, removing sulfate from water of industrial wastewater. So we using this technology for different type of applications. Okay, so few more points. So by oxidizing the water in reservoirs and lagoon, we increase the DO of the water, and the algae naturally prefer anaerobic situation with lack of oxygen. In the moment we oxidize the water, we eliminate and prevent the growth and blooming of algae. Algae, it's a very common problem in many applications. It's blocking filters, causing trouble in the irrigation system, build biofilm in the pipelines, etc. By doing so, we improve in the oxygen level in the water. It's good for fish if they are in the reservoir, and also for plants. It's one of the most important elements for cell division by plants, and by improving the DO level in the root zone, we actually creating a preferred growing condition for the plant and help us to achieve much closer to the genetic quality of the plant. So there are many benefits of implementing this technology, not only improving the situation with algae, but also we have, if I can put it like side effects to it. Improving water turbidity. This is another thing that happened. Reduction in pathogens level. And as I said before, reduce the usage of chemicals. So a little bit about the floating system. So we have sensors on the system. We monitor both floating system and the ozone generator. And we connect it to a cloud-based control system to monitor the process, to make sure that if something is not functioning properly, we will know it in advance and we don't need to wait to see the effect in the water. So if something goes wrong, we're always aware of it and we can treat it in good timing. So our systems are connected to the cloud for monitoring purposes. Now I would like to share with you two case studies that I personally was involved in the UK. Give you a bit of background. The first site called Dunsdale, located in Staffordshire in the Midland of the UK. The challenge was a reservoir that was full of algae in the summer. It's a 30,000 cubic meter reservoir. We wanted to see how we can overcome this problem because we tried different methods. We tried hydrogen peroxide and other methods to overcome it. And the customer really suffered from a very high load of algae that blocked all of his systems. And in November 21, we installed the two pilot systems in the UK, one in this site and one in another site that I will show you in a minute, in order to see the effects in the water, to see if we can develop a system that will overcome this problem. We start operate it in February 22. 2022 was the hottest summer on record in the UK. I think that in all of Europe. I think that most of us, if not all of us, remember this very hot summer. And the result was very, very positive. We didn't have any algae in the reservoir. We implement nanobubble with ozone. Since then, we also learned about some obstacles and we improved the system since then. We always try to improve ourselves. But the result that we want to achieve, we achieved it very well. And what we learn also is that it's not only treated the water in the reservoir and prevent algae growth, we also managed to break old biofilm that was built in the irrigation line and solve a lot of problems that was there already. So that was a very successful pilot. And at the same time, we made another pilot in parallel, the same time, the same year, for a company called Wilkin & Sons Tiptree, based in East Anglia. This company produces jams and marmalades. They grow their own fruit. And the process of the jam production have wastewater, which contain high load of organic matter. And they wanted to utilize this water for irrigation instead of get rid of it. They want to utilize it for irrigation. This is East Anglia. It's the driest county in the UK. Actually, by definition, it's actually defined as a desert, funnily enough, if you take in the amount of rainfall over there. So they really had a need to use the water efficiently. But this water had very poor quality, and they had also problem with algae. So we made another pilot over there, which was very successful. I can tell you that both of these customers that I made the pilot with, after this pilot, they bought more systems for the reservoir. So I think they are quite happy with the result they got. I would like to touch some other applications. This is in Israel. This is extensive wastewater treatment, where the water go to a reservoir, and quite a big reservoir, 500,000 cubic meter, with high daily flow goes into the reservoir. And you can see on the picture above the turbidity of the water and how the water looks like, very poor water quality. Palgei Mayim installed the nanobubble with the ozone, and after 25 days of operation, you can see how the water looks like. Turbidity went down, water quality went better. And on the table before, on the left-hand side, you can see at the bottom chart, you can see the regulatory standards in Israel for wastewater, what we need to achieve. You can see the value before treatment. The COD was 380, BOD 85, TSS 145. After 2 weeks, the COD went to 209, BOD to 35, TSS to 31.6, and after 4 weeks, COD 172, BOD remained 35, and TSS 27. So this is another case study of a different application. This is another reservoir that caused very bad smell all over the area where it is located. And the water for this reservoir comes from it's a wastewater of the industrial estate nearby. And in this reservoir, they had a lot of detergent also, and they had to do something about it because the smell was more than 5 kilometers in radius around the reservoir, and the public complained about it. So Palgei Mayim installed the nanobubble ozone system also in this reservoir. And in less than 2 weeks, the smell disappeared and the water quality improved. And it actually solved the problem. It also broke the detergents in the water that came from the industrial estate. This is the same reservoir. You can see a picture in November 22nd and March 23rd, and how the color of the water in the reservoir has changed. They also measured the DO level on the west bank and the east bank. The system was located closer to the west bank, but it is very easy to see how the DO level increased since the installation and remain quite high. You can also see the effect of the TSS and COD on the chart below. Now, I just want to touch few applications that we are utilize these technologies. So municipal wastewater treatment plants, reservoirs and lagoon, wastewater reservoirs, wells. I will show you another project done in Mexico to treat well water, and industrial wastewater. This project is located in Mexico. It's a town or city that had a challenge that they had peaks of demands. It's very popular place for tourists, and they get sometimes they get a number of crews come at the same time, which increase the population in the city by 10 to 15,000 people, and then they get peak of demand for water supply, and they used to implement the common method of iron removal from the water. We're using chlorine, but they needed to be able to give the demands also for the peaks, and they struggled doing so using the method that they used so far. And then Palgia Mayim work with them to learn the situation, analyze it, and make a long-term plan how to overcome it. And they installed the system that oxidized the iron in the water in order to convert it from liquid to solids that we can filter. Instead of using chlorine, using nanobubble with ozone to oxidize the water. And then after the water is oxidized and the iron becomes solid, they catch it on, they filter it using banks of sand filter. And this way create an online treatment system that can give them the solution for those peaks of demand that I spoke about. Play a short video. You won't hear it because we cannot play sound, but just to show you some pictures from the site during the installation of the system. This is the iron removal solution provided in Mexico. So those black tanks are the reactors for the nanobubble. The water goes through these reactors, the water gets oxidized, and then run through a bank of filters to remove the iron from the water. Another challenge that we are working to overcome is the growth of other plants in the water, not necessarily algae. So this solution is currently under a testing stage. We know that this is also a big problem in Portugal and in many other countries around the world. So we are now in the testing stage to overcome this, to find the complete solution for this problem. And we will be very happy to continue the conversation about this when we finalize this testing. And this is the end of my presentation. If anyone has any question.
Susana,
Diana,
consegue?
Diana. Oh, thank you, Tomer.
Thank you.
Olá, Susana. Eu não sei se posso fazer uma pergunta, não sei se me estão a ouvir.
Pode sim, Carlos. Força.
Em português ou em inglês?
English, please, if you can.
Okay, I have some doubts about the technology. I want to ask you if it can apply when the water is moving with high velocity, like in the big channel, a concrete channel, or in big reservoirs, about 100,000 cubic meters, and the water is running about 100 liters by second. I want to know if the technology as was tested in that kind of situation. Another question is about the type of algae, and if you have data about the plants, aquatic plants too. What's happened to that algae and plants? They die. What is the effect of the technology in these kinds of algae and plants?
Okay, so I will start with the
I
first
think
question. Thank you for the questions. I will start with the first question about treating water that moving in high velocity. So we need to learn each site and the situation in each of the sites, but we need to look at what we're trying to achieve, what is the problem, if it's disinfection, if we're trying to treat algae. And we need, generally speaking, to learn what is the intensity of the process that we need to apply and make sure that we have enough contact time to achieve the goal. And the system is modular. So if we need to treat high volume of water, or if the water is moving fast, the inlet and outlet is running in high velocity, we can modularly install more systems in order to overcome the timing obstacle and just to create more intense oxidizing process. About the type of algae, again, we need to learn each site and what are the problem in each site. But most type of algae that I came across don't like. They like a lack of oxygen and they like anaerobic situation. And when we oxidize the water, they stop blooming. Is that answer the question? I think you are on mute. I cannot hear what you say.
Não estamos a ouvir, Carlos. Tem que ligar
Desculpe. I was asking if you have concrete data about the effects in the algae or in the plants. If they grow, if they die, what's happened with the plants? Well, our experience is that with sun and nutrients and temperature and some running water, the algae and the plants grow very well. They like it very much. So I don't know for sure. Maybe if you can say to us if there is any unit we can visit in Portugal or in Spain to look. And the other question is about the cost. How is the price or the value of the one unit for one reservoir of 100,000 cubic meter?
It really depends on how many units to treat these reservoirs, and And sometimes we will install another system to improve the mixing of the water. So we need to quote the solution based on each application. Okay.
Good morning.
About
Can I put a question, please?
pardon?
Good morning.
Good morning.
I was listening your presentation. My name is Manuel Duarte. I'm from the company Boomlift, and we are very involved in the equipments for cleaning algae on the salty water and potable water. But and my question is the nanobubble technology don't remove the die algae. If you clean the hull, or you must take it out from the tank, you must take it out from the lagoon.
Mhm.
Your system can be installed immediately before any cleaning to be done, or we need to clean before or clean after the application of the bubbles. Because the question of Carlos Marques is very important. Where goes the algae?
Okay, so I've seen some videos and pictures about these problems of those plants that grow, and it looks as it needs to be a combination of a number of solutions in order to overcome it. Not only the nanobubble, it's not the solution for everything. It can contribute to some situation.
Yeah.
We don't say that this is the solution for all of the water problems in the world.
Yeah,
but
there is a real miracle. It's not exactly like that.
So it might be necessary to clean the intense growth. You know, if the water is already full of
because I'm following the situation in several countries, and I participate already in other seminars for plants, invasion plants. We already supply an equipment for Mora in Portugal. We have an equipment working in Mora for cleaning jacintos, that is algae, invasion algae for the rivers. And not only for the jacintos, but for the cleaning all the river that is in Mora. And the solution, the invasion of different kind of algae is amazing. Not only in the rivers, but also some algae that coming from the sea to the rivers, and that are surviving now. And I think it's the question of Carlos Marques is very, very, very important to understand, because maybe, as far as I understand your experience in the nanobubble technology, and I was looking in the other computer, more story about that, and because I'm very interesting to follow this kind of problems in Portugal, not only on the rivers but on the coast. We have big problems in the summer in Algarve that is coming through the coast now from to the north of Portugal. The invasion of algae, it's amazing. They could run in the last seminar that I participate in Lagos in Portugal. One university of Algarve is studying the problem. Also, not only for the algae in the tanks, but also in the coast.
So I think that what we are looking at when it comes to find the ultimate solution for it, it's to combine a number of technologies. We are still in the stage of testing, but it might be a combination of firstly removing the excess of growth, and then to treat it to prevent the continuous growth of the plants. Okay, so we are looking into it in order to find a solution that it's solving the problem and also sustainable.
Yes.
And we are open to to collaborate with other providers in order to bring the
But
solution.
one question that Carlos Marques put to you that is very interesting. your system work in the current waters. That means, for example, in the river, or if we have a canal that for irrigation, for example, that have some movement on the water. You already tested your system on that kind of situation?
Yes, we have systems that working on moving water. We also have solutions for online treatments. So we know also how to handle moving water, not only steady water.
Mm-hmm. Okay, good.
Just a word about the issue of oxidation of algae. Obviously, I have no experience with the algae that grow in Portugal, but assuming that they are more or less the same as the ones that are here, when you apply an ozone concentration of 1 to 2 milligrams per liter for a few minutes, all the turbidity that is caused by the algae is removed completely and the water becomes completely transparent. Now, I cannot attest for sure that the oxidation goes all the way to CO2, but the chlorophyll for sure, and the suspended material is oxidized and disappears into dissolved matter. It probably doesn't go all the way, but I'd say 70, 80%, but the turbidity disappears completely.
But what happened to the die algae?
Well, again, I'm not sure I know what the ones that die, you mean?
Yeah, the ones that you kill with the nanobubbles.
So some of the organic matter goes into the water and becomes dissolved matter. If you look mass-wise, probably 20% of it will remain. And the question of how much of it is oxidized and how much remains is a matter of the concentration of the ozone, the time that you apply. If the contact time is high, eventually, if the pH is relatively high and hydroxyl radicals form, then it will go all the way to CO2. pH is low, temperature is low, it will go only partially. It depends on the situation.
You just take it in potable water or in salty water also?
It will work either way. What I've seen myself was with fresh water, but it should work also with salty water, seawater.
Thank you.
I want to add something more to say. One of the biggest problems that all the plants that died and the algae that going down to the bottom of the water in the lake or whatever, then you start to have layers. Then the top layer is get the sun, the UV, and have oxygen from the air, and the bottom layer will be anaerobic. One of the things that the nanobubbles, when you inject nanobubbles to the water, the nanobubbles get also to the bottom, and then you have no layers. You have the same oxidation on the top and in the bottom, and then you don't get in the summer the anaerobic layers got to the top, and then you have a lot of problems.
Uprising, it's called.
Diana, we can continue with the...
Yes.
I think.
Alguém tem
Não
mais
houver
alguma
mais
questão que
questões.
possa... Sim. Força,
All
Gonçalo.
right. Sorry? Shall I share?
Can I just put one last question? You are planning to install any ozone generator in Portugal, or you already have it?
We're going to install soon, hopefully.
Okay, that means we can evaluate that soon in Portugal. But outside of Portugal, it's any... You already say that in UK you have it.
Yeah, we have it in the UK running for quite some time. And if you would like to visit the UK to see system in operation,
yeah, but
we
UK
can
is
arrange
completely
it.
kind of weather different. They raining so much. It's not exactly the same number of sun hours that we have in Portugal, for example.
So we can arrange it also in Israel. It's a weather that it's warmer than Portugal.
Very good.
Very welcome to visit.
Okay, great.
Okay, Ori. So hand over to you.
All right. I guess you can see the presentation, right? All right.
Yes, Professor. Yes, we can see it.
Yes.
Great. Fine. So, actually, I thought I would be the first one introducing the issue, but as it appears, I'm the second one, so I'll go rather quickly about some of the things. A few words about myself. I am an aquatic chemistry professional. I do water and wastewater treatment process development, and most of the emphasis in my research is on physical-chemical treatment approaches. I do a lot of separation processes using membranes, doing ion exchange, precipitation of solids, adsorption, whatever you like that's related to physical-chemical processes. I do a lot of electrolysis, both for ammonia removal, for example, ammonia oxidation and disinfection, and many other things. I'm quite a lot of time in the business, more than 20 years, published quite a lot in many journals, also prestigious journals. I currently serve as the Dean of the Faculty of Civil and Environmental Engineering at the Technion. Technion is the best technical university in Israel, normally one of the 10 best technical universities in the world, and almost all the years within the first 100 universities altogether. I used to be the Water Research Institute head, and also I was between 2017 and 2019, I was the dean in a university in China, which is a subsidiary of Technion. I do a lot of practical research, basic and practical research. I have many patents and 5 commercialized ventures, meaning research that came off the lab that became commercialized. I was asked to give some theory and practice about ozone-based oxidation and mostly disinfection. The talk that Tomer gave before mostly was focused on disinfection issues. on oxidation issues. I will focus mostly on disinfection. And I apologize in advance if the talk is too trivial for some, because I've noticed that there are many professionals in the audience, and I'll try to run rather quickly. If you feel that something is unclear, please stop me and ask. So ozone in Greek means to smell, and it has a very distinctive smell, and many people, or most people, can smell it at very low concentrations in the gas phase. At around 20-25 degrees, it can dissolve in the water up to around 15 milligrams per liter. If you go down to 4 degrees Celsius, you can go up to an equilibrium concentration of around 40 milligrams per liter. So the lower the temperature, the higher the concentration. Obviously, it goes the same way for all the gases. Once ozone dissolves in water, it readily reacts with hydroxyl ions to form hydroxyl radicals. Hydroxyl radicals are obviously species that have only one electron at the outer sphere, and they want to react very quickly to get the second electron to close the sphere, and therefore they are very, very reactive. Once the ozone is in the water, it forms ozone dissolved and also radicals. So the reaction with microorganisms or organic matter or whatever you want to oxidize may be a function of ozone disinfection or radical oxidation, mostly depending on pH. The higher the pH, the higher the hydroxide concentration, and therefore the higher amount of radicals that you can produce from the ozone. At normal pH values of around neutrality, most of the ozone will remain as ozone. and the reactions that we will see will be connected to ozone and not to radicals. Now, ozone degrades relatively rapidly in water. The time of the reaction of the degradation is in the order of minutes. I'll show you later on. It is dependent on temperature and on pH, but basically ozone doesn't leave a residual concentration in the water after the application, as opposed to chlorine, for example, that can stay in the water for days. Ozone disappears in a matter of hours at the most. Now, a few words about CT, or concentration times contact time. We all know the Chick-Watson model that was suggested 100 years ago and still serves. The number of microorganisms after a certain time relative to the original number is a function of a certain constant, and times the concentration of the disinfectant, ozone in this case, to the power of n, and the time of contact. Now, in most cases, we take n to be 1, so we can define the ability to remove or to inactivate microorganisms as a function of the multiplication C times T. And there are many tables, we all obviously are aware of this, I'm sure, that gives us the amount of degradation in logs, or the orders of magnitude of the inactivation of different microorganisms as a function of the concentration times time. And you can see in the upper table that ozone is much more efficient in reducing the concentration of both viruses and parasite, Giardia lamblia, that you see at the bottom. You can see that the requirement for CT for ozone is much, much lower than for free chlorine, say for viruses and for parasites. Let's look at the parasite, for example. At a temperature of 20 degrees, you require a CT of 0.72 in order to get rid of 2 orders of magnitude or 3 orders of magnitude of Giardia lamblia, whereas free chlorine would be required in the tens or even 100, depending on pH. Ozone is pH independent between pH 6 and 9. We can continue looking into CT values for inactivation of certain species by ozone. This one is again Giardia cysts by ozone. You can see that the values are low, up to 1 or something like that, or maybe 2, in order to get rid of 3 orders of magnitude of this parasite. And if we look at the Cryptosporidium parvum, which is the most durable microorganism, which often serves as a cornerstone for design of disinfection units, you can see that at 15 degrees Celsius, you require around 20 CT. In actual fact, no other disinfectant can allow you to remove 3 orders of magnitude of crypto apart from ozone. It's the only one, and if you have this problem in your water, this is the only solution that you will have. If we look at the removal mechanisms of ozone, then normally it attacks the walls of the cells. It gets in and damages the genetic material. That's a general description, but if we go down and look at the cysts of Cryptosporidium parvum, for example, what it does to them, if you count them before and after the application of ozone, you will see no change. But if you looked at the infectivity, the ability of them to infect, to cause a disease, then you will see that it goes down considerably, because what happens to the cysts is that the ozone ruptures. You can see it on the right-hand side. After 480 seconds of application by ozone, the cyst simply breaks down. And you can see here, I've brought some formulas for characterizing the amount of logs that would be reduced for Cryptosporidium and for Giardia lamblia as a function of CT. You can see that the temperature is involved. By the way, the temperature here is in Celsius. The temperature on the power. And you can see again that for crypto, the requirement is much, much higher for CT than for Giardia, because crypto is the most problematic substance or microorganism to get rid of. Now, with regard to water degradation rates of ozone, as we said at the beginning, ozone reacts with hydroxide ions to form a radical, which again reacts with ozone to form an hydroxyl radical. And therefore, if we have a high concentration of OH minus, obviously at high pH, then the auto degradation of ozone will be relatively rapid. And after a few minutes, you can see in the graph, after a few minutes, the concentration goes down from 100% to almost nothing after 10 minutes. When you have substances that can act as scavengers for radicals, then the rate slows down. And the reason is that we said before that the radicals react once they form, they react themselves with ozone. And when you have something that takes them up, like carbonate, for example, or phosphate, then there is a lower amount of radicals and the ozone remains in the water for a larger amount of time. pH obviously affects the auto degradation exactly because of the same reason as we said before. More OH minus, more radicals form, and then the chain reaction continues. So you can see that at a pH 10.4 here, the degradation is in almost no time, like 2 minutes, it goes down from 100% to nothing. Whereas at pH 7.6, it takes a much, much longer time. This is at 15 degrees Celsius. And if you look at higher temperatures, then you can see that the higher the temperature, the lower the half-life time of the ozone with regard to its auto degradation. And therefore, we have to assume that once we oxidize or disinfect with ozone, it does what it does, but later on, nothing will remain in the water after an hour or something like that. All right, and now we need to talk about possible byproducts. Any disinfectant has a byproduct in the water. Ozone is no different in this case, but ozone doesn't form trialomethanes or haloacetic acids, which are the most problematic byproducts that we get from applying chlorine. But it does form a bromate, BrO3 minus, if you have a bromide, a substantial bromide concentration in the water. Now, this is obviously problematic mostly for drinking water, but you don't want to get bromate in any type of water. It's not a very pleasant substance. And the EPA has named its highest concentration at 0.05 micrograms per liter for drinking water. This is not a problem when you don't have bromide in the water, and this is the first thing that I would check when I see if I want to apply ozone in water. There are other byproducts, aldehydes or stuff like that, when ozone reacts with them, but it's a lesser problem. Some research also mentioned that bromoform is formed from certain reactions of ozone in water with organic matter in water, natural organic matter. But again, this is a much lower concentration of bromoform than what you normally get when you apply chlorine. So it's a lesser of a problem, and bromoform remains the main byproduct of ozone application in water. And you can see the formation reactions for bromoform. The lower the pH, the less bromoform that you get, because obviously OBr minus and HOBr are a weak acid system with a pK of 8.6. So if you go below 8.6, HOBr will dominate, and you see that the reaction is with OBr minus, and therefore the lower the pH, the lower the problem. Okay, if I summarize the advantages and disadvantages of using ozone as a disinfectant, firstly, it's a very strong agent. So you require very low to very low CT values in order to get what you want, a certain removal of microorganisms. It is the most efficient substance against protozoa or parasite cysts. It is easily generated on site. And the disadvantages are that it has no residual. And if bromide is present, then you need to look into possible bromide formation. So that was a general introduction of ozonation for disinfection. And now a few words about nano and micro bubbles. Most of what I am going to say here was already said by Tomer, so I'll go very rapidly through it. So the diameter ranges from 10 micrometers to 10 tenths of nanometers. Obviously, the small diameter increases the contact surface area. That's one thing. And the other thing is that the retention time of the bubbles in the water is very, very long. Basically, they can remain there forever because they do not go up, because the very small diameter and the fact that they are at the size more or less of molecules, and therefore they are very reactive and remain in the water attached to something, and therefore you can enjoy all of the ozone that you have formed that will eventually go into the water. The transfer between gas phase and aqueous phase is almost 100%, which is obviously very, very different than when you perform the same thing with macro bubbles, or large bubbles. So the long-term stability of the bubbles, along with the high surface area to water volume ratio, makes this technique very efficient. Now, in this slide, I simply give you results from the literature. Obviously, the company Palgei Mayim have their own results, but I'm an outsider. I can get my results from the literature, and you can see quite easily that the concentrations of ozone that you get, and also of oxygen eventually, once it degrades down to oxygen, are much, much higher for the same amount of ozone that you apply, because of the very large retention time that the bubbles have in the water. And that's the main issue with this type of technology. It allows you to be more efficient because you apply a certain amount, and that amount can work for you until basically it is diminished, and the transfer of gas to aqueous phase is almost complete. This is it. Thank you.
Thank you, Professor. Diana, acho que agora então poderíamos passar a uma fase de questões.
Thank you, Ori, for your presentation.
Sure.
Gonçalo, sim, eu acho que se houver questões, podem ser colocadas agora, tanto para o Ori como para o Tomer. Ou Tomer, alguém tem questões? So, Tomer, maybe you can show us some more examples of the technology. You have more videos or examples?
You talking to me to show you more examples
Yes.
of the
Yes.
technology? Okay. I prepared this presentation. What else? I can share with you videos. I can send you some links if that helps, to share with everybody. Currently, I have this.
Do you have any case in Portugal where you can see and visit the application of your technology, or near Portugal, in Spain?
We didn't yet had any case study made in Portugal or in Spain. What I can suggest, it's if you want, we can arrange to go to Israel and to show you different type of application. It's very well advanced over there and developed in many different type of applications. So if you're happy to come to Israel, we will be very happy to arrange it.
And tell me, do you find any impact on fishes and other animals with the application of this technology?
I think maybe Chagai from Palgei Mayim is sitting there. He can share with you what we are doing now when it comes to fish production using this technology. Hagai, would you like to share it?
I actually I don't have what to show yet, but for your first question, today in this time we have a system working in the UK and also in Mexico, and very soon next week in Colombia. In Israel we have many applications in the reservoirs, floating systems. We have also H2S removal in a big slaughterhouse in Israel. And also we're building a full-scale system of disinfection of effluents, secondary effluents. And also we do a sludge oxidation for aerobic digester. And so we have many things that we're doing right now. For what you ask for the water culture of growing fish, we starting in this April with the Israeli Association of Fish Growing. We're going to add systems special for this fish growing, because in Israel we have a big issue because of the high temperatures. They cannot get enough oxygen, and then the fish is not growing well. So now we start to work with them and to build system that's special for this water culture. We also work with Japanese partners in Japan, and they are already working with this technology for fish farming. But I don't have all the data, so very soon I will have the data from these tests we're going to do in Israel, and we will send you.
Can I put a question now? That means you talk about many countries in the world, and in Europe you just talk about UK. Could I think, or
That is
maybe
now out
not,
of
that
Europe.
is not a European product certification? That means you don't have European certification for the application of your product?
We don't look. It's a new technology, and there is already other companies that do nanobubbles all over the world.
Yes.
It's not the place. We just need to get the clients, because it's not easy to get in a new technology. But we think, and Tomer also working and have many customers that want to buy this system, and we're gonna have this year we're gonna have more application in Europe.
Okay, but if we install a situation like that in Portugal, we can have official European certification from your products, or not yet?
The moment we sell it in Europe, we will apply for certification. It's just a matter of bureaucracy. It's not going
But that
to
will
be
take time.
Pardon?
But that will take time and could create some difficulties in certain situations.
We will solve it. We have the
Yeah,
experience.
I will believe, but the problem, who will be the first one?
It's not a problem.
Well,
Okay.
it's a decision. It's a decision. Exactly.
Yes.
I like optimism.
Yeah,
But
exactly.
the final question. Esta é a última pergunta. Not the final question of the seminar. My final question.
I just want to say one word, please, about the regulation in Europe. All the system we are building and design, we designed it to be accepted by the regulatory in Europe, by the limited of ozone and everything. We designed it before to get stand with the right regulations. If it's in Europe or in Mexico or in Colombia or in Israel. In Israel we also have very, very strong regulations.
Okay. So I don't know, we'll answer this question. For example, one equipment to install in a reservoir of about 30,000 cubic meters of water, how much does it cost? To have an idea of the amount of this investment.
About the prices and cost,
Yes.
I think it's more professional that in the meeting we're going to make front. We will each application will be different, so it's after the webinar we will set meetings with the people that will be interesting, and then we will present it.
Okay.
Thank you. Gonzalo?
Sim, se não houver mais nenhuma questão para ser colocada. Any question?
Até podem colocar em português, que depois o Gonçalo pode fazer
Sim.
a tradução.
Se quiserem, podem colocar a questão em português e poderemos fazer a
I
tradução.
can do it again. I see that I'm the first, I'm one of the guys very interesting in this. I make a lot of questions. Okay. As far I was making some investigation about these nano bubbles, it's already some companies like Artemis, Triton, and some others in Europe, mainly in Italy, that have this kind of technology for, eu não sei como é que se diz estufas em inglês, create
Greenhouse.
water for irrigations in
Greenhouse.
greenhouse, yeah. Is a similar technology that they have for the irrigation in greenhouses. Much lower, not so big as the system that your systems, and your systems could be very interesting, but I'm really concerned about the possibility of that be European certification, because all your products are made in Israel, correct?
Well, I distribute a lot of products from Israel into Europe and the UK, and we get the European certification. This is not going to be an obstacle. We can sort it out.
Okay. But you know that is always a concern. If someone make an investment, is always a concern. I think that
É claro, isso é a situação. Não só no isso tecnologias, também no outros.
yeah, exactly, yeah.
Yeah.
But that could cost time and money, additional to the investment.
We are up for the challenge.
Okay, thank you.
Thank you.
Thank you. Gonzalo?
Mais alguma questão? Any more questions? Se quiser, volto a frisar, se quiserem colocar alguma questão em português, poderemos traduzir. Diana e Rui, parece que não há mais questões. Então, eu vou fazer aqui um bocadinho um resumo, algumas conclusões, as 3 conclusões. Na realidade, portanto, as tecnologias realistas que estamos aqui a apresentar já estão a ser testadas e provadas em várias geografias, e que poderão trazer soluções eficazes para problemas em Portugal. Para isso, consideramos que é muito importante, e para além destas tecnologias que tivemos aqui a demonstrar, existem outras, e por isso consideramos que é muito importante, para avaliar, e isso foi aqui frisado também durante o seminário, avaliar a sua adequabilidade ao mercado português, a desenvolver, e estamos totalmente disponíveis. Aliás, também gostaríamos de lançar já este repto, desenvolver alguns projetos piloto com associações de regantes para testar diferentes tipos de tecnologias em diferentes condições para diferentes problemas. Portanto, nesse aspecto, e pegando um bocadinho naquilo que o Yair também já tinha aqui dito, que nós faremos um contacto direto com todos os presentes, no sentido de nos disponibilizarmos para olhar primeiro para os problemas que cada um tem e, nesse sentido, com base naquilo que são as tecnologias que temos disponíveis e com base também em eventuais parcerias que poderemos estabelecer, desenvolver soluções para resolver ou minimizar o impacto dos problemas que têm. Na realidade, parece-nos que as soluções que temos, e para além de se poderem afigurar bastante mais baratas, também bastante mais eficazes, mas sim, ainda não houve, nomeadamente no que diz respeito à nanobubbles, não houve aqui não há nenhum exemplo em Portugal para poder ser mostrado. Por isso, a ideia também deste seminário era não só fazer uma primeira apresentação sobre esta tecnologia, mas também estabelecermos aqui contactos para podermos desenvolver, então, volto a frisar, o primeiro piloto, ou os primeiros pilotos aqui em Portugal, em que, e também falando um bocadinho sobre, porque também nos foi levantado esse tema do Jacintago e os problemas que tem, e, por exemplo, o Manuel Duarte também falou nesse aspecto. O Tomer referiu, portanto, há aqui o trabalho de desenvolvimento de uma parceria, de um conjunto de várias tecnologias que estão a ser integradas no sentido de tentar resolver o problema. E por isso também poderemos olhar e terem atenção a alguns sistemas que já estão a ser utilizados aqui em Portugal, nomeadamente para a remoção, como o Manuel também tinha referido, e combinar com sistemas e com tecnologias que possam ser utilizadas também e possam já ter sido desenvolvidas em Israel. O que é importante aqui, parece-me mesmo só para finalizar, o que é importante aqui parece-me que é encontrarmos soluções que sejam eficazes, baratas, e que na realidade tenham o menor impacto possível nos ecossistemas do ponto de vista químico e biológico. Neste sentido, parece-me que poderemos encontrar e que há uma disponibilidade grande de tecnologias que, combinadas ou per si, poderão, mediante os vários casos, ser aplicadas. Para isso, então, também quero já agora aproveitar também para agradecer a todos e desafiá-los para que pensem, porque em projetos piloto que possamos desenvolver juntamente convosco, qualquer um dos, dos presentes, no sentido de termos soluções para solucionar, passa a redundância, portanto, aquilo que são os vossos principais problemas que encontram nos sistemas de rega e outros. Agradecer também à FENARREG, ao Rui e à Diana por esta possibilidade e obrigado a todos.
Gonçalo, obrigado. Eu presumo que não deverá haver, não sei se não haverá mais perguntas, peço não obrigado pela tua intervenção final e obviamente em nome da FENARREG, aquilo que nós pedimos aos nossos associados é que estejam completamente disponíveis para testarem estas inovações. No essencial, isto é um assunto que nos interessa a quase todos, ou se não mesmo a todos, e à medida que vamos baixando no continente, no país com temperaturas mais elevadas e mais sol, então isto torna-se um problema realmente complicado. E, portanto, o que eu pedi aos associados é que, eventualmente, se me permites, Gonçalo, falando através da FENARREG, com a Diana, fazendo da ponte, que ponham as questões, que não tenham receio para as questões. Eu já estou com vontade de ser um projeto piloto, mas que utilizem a FENARREG no bom sentido para fazer essa ponte. E se, obviamente, nós conseguirmos aqui alguns bons resultados, isto é bom para todos. E, enfim, é esta nota final que eu gostaria de deixar. Diana, não sei se mais alguma coisa queres dizer.
Oh, Rui, parece que entraram aqui duas questões
Foi.
agora.
Vamos agora.
E já agora, Diana, queres
Pode avançar, Gonçalo, pode avançar, já que está com a palavra.
deixa-me cá ver, eu acho que foram estas duas, não é? As duas últimas. Ok. So the first question is if the fishes on the water are affected by the system of nanobubbles.
Or not.
This is the first question. And the second one is how Israel has been leading or has been dealing with the problem of Jacinto d'Água. Tomer, help me how to translate it into Israeli.
What was the second question?
Second question is how Israel has been dealing with the problem with Jacinto de Água.
Jacinto de Água.
Eschornia crapices. The name in Latin is Eschornia crassipes.
Tomer, eu vou traduzir para hebraico. תומר, מה שהם שואלים זה איך מטפלים בישראל ביקינטון ובכל הצמחים האחרים.
You can see.
Look at this picture.
Yeah, we've seen it.
תן איזה הברקה ולא להיכנס יותר מדי לעומק.
Okay, so as we said before, we are working on this solution. Now it's going to be probably combined of number of activities. One of them would be if the situation is so bad, is to remove it from the water.
Interrupt now.
Let me just.
Can I just make an interruption?
Yeah,
we already tested this situation in Portugal, and we know how to clean it. The problem is to maintain it. It's two different things.
So this is why we are working on a complete solution. Cleaning it's one of them, but maintain it's the challenge. Okay, you know how to clean it. It's great. We're trying to find the complete mechanism to maintain it afterwards, so you don't need to go and clean it every time again, and to make it more sustainable and cost effective. I always like to finalize the pilots before I come and says I have a solution, because I would like to be personally confident that I have the appropriate solution, and this is why I touched it a little bit and didn't go into more deep of details, because we're still working on it. Okay, so give us some time. But one of the things that we are doing quite okay is to learn the obstacles and then to find the complete solution for it. So this is something that we learn. It's a big problem also in Portugal, and we would like to try our best to help you to overcome it.
Tomer, the other question,
Yair, deixa-me só, posso só resumir muito rapidamente aqui a resposta do Tomer, e que é basicamente, neste momento há soluções já para retirar o jacinto de água. Aliás, o Manel representa uma tecnologia que tem essa capacidade. O problema é que neste momento ainda não existe para, como até está aqui colocado na questão, soluções para que haja a manutenção da qualidade do espelho de água, por exemplo, e para que não seja novamente afetado. E o que o Tomer está a dizer é que se está a trabalhar em soluções que depois, conjugadas com as soluções que já existem de retirada do jacinto, estão-se a trabalhar em soluções combinadas no futuro para fazer a manutenção dos espelhos de água, portanto, a manutenção da água. Portanto, assim, basicamente, acho que é isto, e poderemos, obviamente, depois dentro em breve, se calhar pode ser também um piloto que possamos vir a desenvolver aqui no país, poderia até ser bastante interessante.
Essa,
Segunda questão. E aí, second question, please.
תומר, הם שואלים, האם אנחנו יכולים במקום שיש עצות, האם אנחנו צריכים להוציא קודם את העצות ואז לשים את המערכת, או שאפשר לשים אותה באגם שיש בו עצות?
You can install the system in a lake where you already have algae, and it will reduce the amount of algae and prevent it as the system is operating. In most cases, maybe we'll find in some places a specific type of algae that behave differently, but from our experience, wherever you have algae and we install the system, it's actually eliminate the problem. You don't need to. We didn't need to remove the algae beforehand. We need to differentiate the plants that we spoke about and algae. It's two different scenarios. And you asked me something about the fish, I think, also. So we're looking also to implement this technology in salmon farms, for example. A lot of salmon production is moving now from the sea into the shore. And one of the major issues is disinfection. So we also in the process to do pilot on salmon farms. The amount of ozone that we are implementing, it's very little. So it's not causing any harm to the fish. It can actually benefit the fish by improving the oxygen level in the water and preventing viruses, etc.
Ok, então para traduzir, que esta tecnologia também, como já tinha sido referida, até está a ser estudada para a implementação de projetos de aquacultura, e que, na realidade, portanto, utiliza muito pouca quantidade de ozono, percentualmente, e que o objetivo, portanto, não afeta os peixes negativamente, até melhora a sua qualidade de vida, porque melhora os teores de oxigênio na água. Mais questões? More questions?
Não havendo mais questões, eu acho que depois, se surgirem outras questões, quando partilharmos as apresentações, podem nos enviar essas questões mais concretas, com mais algum pormenor, nós fazemos chegar e entrarão em contacto e teremos a resposta. Acho que isso não será um problema, não é, Gonçalo?
Claro, e
Querida,
eu agradeço desde já a vossa disponibilidade até para nos
talvez às vezes,
apoiarem
exata-
neste contactos com os vossos
sim.
tatis. Estamos
Ao verem a
totalmente
apresentação
disponíveis.
com mais detalhe e com mais atenção, poderão surgir então outras questões. E por isso pedimos depois
Perfeito.
que nos façam chegar. Do lado da FENARREG, como já tinha dito o Rui, agradecemos a vossa participação. Tivemos aqui um bom grupo, foi um bom debate. E agradecer também a vossa colaboração e esta parceria para fazer face a estes problemas das associações de regantes ou de outras entidades. Isto é muito comum, quer é reservatórios, rios ou canais. Obrigado mais uma vez. Thank you so much, Omar, Ori, Yair e a todos vós. E vamos, entretanto, partilhar as apresentações e os contactos para que possam entrar, está bem? Rui, não sei se quer
Muito
dar mais
obrigado.
algumas palavras.
Muito obrigado.
Thank you very much for your time.
Thanks a lot.
Thank you, Ori.
Omar and Dori, thank you very much for your
Thank
time.
you very much, and
Bye-bye.
everyone, welcome to Israel.
Muito obrigado.
Okay, great. Thank you, guys.
Take care. Bye-bye.
Yeah.
Bye-bye.
Bye.
Tchau.